Hi, let me introduce you to Karen, who is going to be my son, and then later she's going to be my camera person. Scientists, sometimes I call them pseudo-scientists, are always dreaming up distances and speeds that are scarcely believable, but we believe them because they're scientists. So this is the globe. As you can see, it's a ball. Well, I play golf, so I should know what a ball can do. They tell me that it revolves around its axis, and at the equator it's moving at over 1,000 miles an hour. Here in Brighton it would be about 700 miles an hour. They tell me that it goes around the sun at 67,000 miles an hour. I can see that. A ball can move in an arc while spinning on its axis. Then they tell me that the Earth and the Sun and the entire solar system traverses the Milky Way at 500,000 miles an hour. I get it, just about. You see, the Sun is moving around in an arc and the Earth is spiralling around the Sun. And then they tell me that the Earth and the Sun and everything else is moving away from the Big Bang at millions of miles an hour. They say 32 times faster than a speeding bullet. Here I'm starting to get doubtful. And then they tell me that the moon is also a revolving ball, and the moon does everything that the Earth is doing, which means it's going in 3 different directions at the same time, and it also orbits the Earth. So it's going at 4 different directions at the same time at these fabulous speeds. And this is where I say no, I don't believe that a ball can do that much. So now I'm going to make the comparison between the Earth and the Sun. And to show the Earth, I'm going to use a blue marble. I got it from a NASA Photoshop. Oh, so here we are, on this side of the Sun. This is the angle of the Earth, and this is Brighton, this green dot. And we're going to say that it's June, and it's 1 o'clock in the afternoon, and it's a nice sunny day in Brighton. I'm going to go over the other side and have a look at the situation in December. But first of all, just to illustrate, I'm going to show what happens in 24 hours time. We're going to jump forward 24 hours. Here we go. There we go. We've gone 1 degree in our arc of travel to the other side, and we've gone 360 degrees round, orbiting our own axis. So naturally, Brighton comes back to the same place. And every 24 hours, Brighton will have to keep coming back to the same place. That's the law. And it's absolutely logical. It can't be any other way. So, I'm going over the other side. I can't do this 180 times though, because it would take all night. Here we go. There's no trickery involved. Brighton keeps coming back to the same place. It has to. So here we are in December, and it's 1 o'clock in the afternoon in Brighton, and what do we find? Well, we find a problem, because this half of the Earth is getting the sunlight, and this half is not. So Brighton is in darkness. It's night time, and it's 1 o'clock in the afternoon in December. It doesn't make sense. Copernicus, I'm afraid you've let us down. It's gone wrong. And now, I'm going to take a look at these 2 positions of the Earth, the June position and the December position. Right, now the first thing that we notice is that these 2 positions are 186 million miles apart. That's a long distance. One would think that if you were looking out at a star, there would be a parallax change. Now, It's surprising, but 100 years or so ago, not all scientists were enmeshed in Jesuit science and Freemasonry. Some of them had independent minds and did experiments. And I'm going to describe one of these experiments to you now. So we're over here, in the June position of the Earth. This scientist points the telescope at the North Star, Polaris, and he makes sure that Polaris is smack in the centre of the crosshairs of his telescope. And then he sets his telescope in concrete so that it can't move. And then he waits for 6 months. And he finds himself then on the other side of the Earth, in the December position of the Earth. He looks through the telescope, and lo and behold, Polaris is still smack in the centre of the crosshairs. It hasn't moved a jot. Now, as you can imagine, this caused consternation in the scientific community. They had to get out of this one. They had to do something, and they had to do it fast. And what did they do? Well, I'll tell you, they did what they always do. They changed the distances. They put back the nearest star to 25 trillion miles, and they put back Polaris, just to make sure, to 400 trillion miles. Well, the problem was solved. They could say that there wouldn't be any parallax change because 186 miles is absolutely nothing compared with 400 trillion miles, and they'd done their job and they could go home. Trouble is, if each and every one of you want to continue to believe in the heliocentric system, you have to believe that the human eyes, good but not the best in the animal kingdom, can focus on Polaris, a heavenly body that is 400 trillion miles away. I don't think so. Well, thank you very much, Karen. And now we go onto the moon, and if we could, we'd be the first. But that's a separate question. So how come the moon being so small and the sun being so big that we get a perfect eclipse, where the moon and the sun appear to be the same size? Well, says the scientist, it is a bit of a coincidence, but it just happens that the moon is 400 times smaller than the sun and 400 times further away from the sun than it is to Earth. Therefore, from Earth, they seem to be the same size, and we get a perfect eclipse. Very well, but that's a big coincidence. I would say that was getting on for 1,000,000 to 1 coincidence. And how come we never see the other side of the moon, the so-called dark side? Ah yes, say the scientists. It just so happens, it is a bit of a coincidence, but the moon takes 28 days to go around the Earth, and it also takes 28 days to go around its own axis. Right, that explains it then. But it's a big coincidence, isn't it? I mean, this has to be synchronised perfectly, these two timings, because if they were just an itsy-bitsy bit of a second out, we would start to see the other side of the moon after 50 years or so, but we never do. So I think we have another 1,000,000 to 1 coincidence here. Now, what are you supposed to do as a scientist when, in order to further the belief in a system or a theory, such as the heliocentric theory, you need a 1,000,000,000 to 1 coincidence for it to work? Well, I think I know what you're supposed to do. You're supposed to put it in the bin and go back to a drawing board. And the drawing board would be the flat Earth model, which worked perfectly well for 4,000 years or so before Copernicus. There were smart people around. I mean, they built the pyramids, something that we couldn't do today. So, how does it work on the flat Earth model? Well, the sun is only 3,000 miles up, and the moon likewise. And they circle around the Earth once every 24 hours. And they oscillate between the two tropics in order to cause the seasons. They oscillate throughout the year to cause the seasons. And because the sun travels slightly faster than the moon, every now and then it overtakes the moon, and hence we get a perfect eclipse. This is simple, this is elegant, and it doesn't need any coincidences. Right, let's go on to aeroplanes. Now an aeroplane going from continent to continent obviously has to negotiate the curvature of the Earth. And it's very important that an aeroplane maintains its altitude. The cruising speed of an aeroplane is about 500 miles an hour. And it works out mathematically that in order to maintain your altitude, you would have to dive down half a mile every minute. And yet no pilot or autopilot ever has to do this. And the only reason is that the Earth is more or less flat. Second thing about aeroplanes, east-west travel. Say, and west-east travel. Say London to New York, New York to London. Well, it works out that the times are about 7.5 hours, whichever way you go. And this doesn't make any sense at all on a spinning globe. If you were to take off from Heathrow and you're heading towards New York at 500 miles an hour, cutting through the air towards New York, well, New York, according to the globe, which is spinning, is heading towards you at 700 miles an hour. So it should only take about 3 hours to get there then. Conversely, you take off from New York, you're going towards London at 500 miles an hour, but London is moving away from you at 700 miles an hour. You'd never get there. If you could stay in the air long enough, London would catch you up from behind. But of course this is a nonsense. And the reason is because the Earth is obviously still. Just as we can tell it's still here in this room, or if we go outside tomorrow and take a look around. These pseudoscientists are trying to take our senses away from us. Right. Let's go on to the third aspect of aeroplanes. The southern hemisphere. You see, on the globe, the southern hemisphere contracts as it gets near to the pole, the South Pole. That's the nature of a ball. Here on the flat Earth we can see that the southern hemisphere actually expands as you go into the southern hemisphere. How does this work out with airplane travel? Well, I'm going to give you one example, but I promise you that between continent and continent in the southern hemisphere, all of the examples are the same as this one. So say you want to go from Australia, Adelaide, to Buenos Aires in South America. Well, the obvious way to go on the globe would be to nip over to New Zealand, refuel your tanks, and then do these maybe 6,500 miles to Buenos Aires. It should take about 18 hours. But there's no such flight. And I'm going to tell you what you'd actually have to do. You would have to catch a plane from Adelaide, deep in the southern hemisphere, up across the equator, deep in the northern hemisphere to San Francisco, then down to Houston, and finally down to Buenos Aires. It doesn't make any sense at all. It's uneconomic. Let's have a look and see how it works out on the flat Earth map. So we start Adelaide, we go in a straight line to San Francisco, we go down to Houston, and then bear left slightly to Buenos Aires. It makes perfect sense. The only way to travel. Right. Now this is the biggest proof of all. The Antarctic. You see, on the globe, the Antarctic is a fairly small continent. I would estimate it's about 12,000 miles to circumnavigate. Should take between 6 and 9 months for the average ship. But here on the flat Earth, the Antarctic is an icy plateau that goes all the way around the outside. So if you were to go as near as you could to the edge of this icy plateau, it would be a vast, vast journey. So how does it work out? I mean, has there been an expedition or a ship that has circumnavigated the Antarctic? Well, yes, there's been 3. Captain Cook, Captain Clark Ross, and the Challenger expedition. And they all came to the same conclusions. They all kept records of everything they did. They all took between 3 and 4.5 years, and they all clocked over 70,000 miles. And on the globe, that's just plain ridiculous. On the flat Earth, as per usual, it makes perfect sense. Another aspect of Antarctica is the comparison with the Arctic, because they should have the same climate. Doesn't matter how you work it, doesn't matter about the angle of the Earth. If it favours you for sunshine on one side, it will not favour you for sunshine on the other side of the sun, because the angle stays the same. So, no matter how you look at it, you should get the same sort of climate on the North Pole as the South Pole. It's also reality. Well, the reality is conceded by everybody from both sides of the fence. The Antarctic is 50 degrees on average colder than the Arctic. Doesn't make any sense on the globe. Of course, on the flat Earth, as per usual, it makes perfect sense. Because here you've got the Arctic surrounded by temperate countries and surrounded by the motions of the sun. The Antarctic, on the other hand, is isolated on the outside of the map. It's no surprise at all that it's 50 degrees colder on average. Now, you're probably thinking, because I've shown you this flat Earth map 4 or 5 times, but it's weird, it doesn't make any sense, can't be true, and you've never seen the like of it before. But you have, in actual fact, seen the like of it before thousands of times. Because if we bear down onto this image, we'll see that the flat Earth is represented by the flag of the United Nations. That's a bit strange, isn't it? And you'll also see a grid. Looks a bit like a dartboard. And it has 33 sections, or 33 degrees. Now what do we know about the United Nations? Well, by their own admission, the spokesmen are always talking about a one world government. It's a staging post for the one world government, or the New World Order. The other thing we know, by their own admission, is that they're controlled by Freemasonry. So what are these Freemasons trying to tell us by making their emblem, their flag, the flat Earth? Well, I think that they're trying to say to us that they are so convinced, that we are so convinced that we live on a globe, that they are putting it in our face, hidden in plain sight, that the Earth is flat. Thank you. Do you think we got it all, Karen?